Hello world, it's so good to see you. It's so good to be back here on YouTube after so many years, and I'm here to welcome you to my new channel where we will be covering a lot of programming related content. Specifically on this first phase, we'll be covering data structures and algorithms by solving competitive programming exercises, and we'll do this by dividing the content on three series. First, the Codility lessons from 1 to 17, in which we will see concepts ranging from arrays, time complexity, stacks and queues, binary searches, all the way up to dynamic programming. Second, the cracking the coding interview problems, where we will see concepts such as arrays and strings, linked lists, stacks and queues, trees and graphs, bit manipulation, and a couple more. And finally, the start problems in the Competitive Programming 3, the new lower bound of programming contests book, which is an amazing book for practicing these kinds of problems. And it also will be quite extensive and time consuming, since it is a long book. So for these videos, I will assume that you have a basic understanding of data structures like arrays and linked lists and graphs and all of that stuff. But if you don't, I highly recommend that you check other content creators on YouTube, because it will be very useful to have at least a basic understanding before we dive deep into these kind of problems. Also, I'm gonna recommend that you check out Big O notation and understand the concept of analyzing the time complexity of algorithms, because that will be a very important point when we solve this kind of problems, because we want to see if our solution is going to run in an acceptable manner, specifically for inputs that are very large, that could break your program if it's not efficient enough. And we'll also be looking at a little bit of space complexity to see if we're not using too much memory to solve these problems. And I want to clarify that most of the solutions to these problems will be coded in Python, simply because I want to practice my Python skills, and this channel will be in English exclusively because I want to practice my English. And without further ado, let's hit the ground running with the first exercise, where we will dip our toes in the water with a bit manipulation exercise. It's the first exercise from the Codility lessons. Let's get at it. Okay, so the first thing that we have to do is get into the Codility page, which is app.codility.com/programmers. We're gonna go here into the lessons section. We're going to go to the first lesson, which only has one exercise, that's BinaryGap. We're gonna hit start a test. We're gonna select the Python language, in my case, yep. And we're gonna read the exercise. So it says, a binary gap within a positive integer n is any maximal sequence of consecutive zeros that is surrounded by ones at both ends in the binary representation of n. For example, number 9 has binary representation 1001 and contains a binary gap of length 2. The number 529 has binary representation 1 followed by 4 zeros, a 1, 3 zeros, and a 1, and contains two binary gaps, one of length 4 and one of length 3. The number 20 has a binary representation of 10100 and contains one binary gap of length 1. We have examples for number 15, which contains no binary gaps, and the number 32, which also doesn't contain any binary gaps, since it only has one 1 and it has no sequence of zeros surrounded by a 1. So we are asked to write a function that, given a positive integer n, returns the length of its longest binary gap. The function should return 0 if n doesn't contain a binary gap. We have another example with 1041, which has a binary gap of 5 zeros, and 32, which doesn't have any binary gap. So this is an important part. It says write an efficient algorithm for the following assumptions. N is an integer within the range 1 and 2 to the 31. If you look this number up, it's 2 to the 31, and what this is basically saying us is that all the numbers are going to be at least 32 bits max. So this is not a very complex solution. We're going to do some bit manipulation here to calculate what the length of the maximum binary gap is. We could also do this with strings. It's basically the same idea. We're just gonna have to start from the end and go to the beginning. So let's get rid of this stuff and let's get at it. So first of all, we are going to know if we are in a binary gap. We want to know how long is it. So current binary gap count, let's start this at 0. We're going to know which one is the maximum binary gap count so far, which will also start at 0. We want to know if we are currently in a binary gap, which we are not because we are just starting, and we'll also need to know what is the previous least significant bit, because we're going to do a comparison to know if we are starting a binary gap or if we are in a binary gap currently. So previous least significant bit, none. Okay, so we're going to start iterating over the number. First, we need to know which is the least significant bit. In this case, we will need to perform the Boolean operation of the number and 1, which will give us the least significant bit. And we need to check if there is a previous least significant bit. So if this is none, meaning we are on the first bit, we are going to assign it for the next iteration. And we're going to do our right shift, our binary right shift of the number, so we can pass on to the next bit. And we're going to continue because we don't want to do anything else in this case. However, once we are on the second bit, we want to know if we are at the beginning of a binary gap or if we are at the or we are continuing a binary gap. So we're gonna set if it's in binary. We're gonna know if it's in a binary gap if the current least significant bit is 0 and the previous least significant bit was a 1. So this is an option that will tell us if we're in a binary gap, and the other option will be to know that we are already in a binary gap. Great. So now we need to check the case where we are ending a binary gap, right? So we will know this if the current bit or least significant bit is a 1 and the previous least significant bit was a 0. So if this happened, we'll know that we are not in a binary gap anymore. So we're going to set this to false. We are going to we're going to need to know if the current gap is bigger than the maximum recorded. So we're going to say the max binary gap count is going to be the maximum between the current maximum binary gap count and the current binary gap count, right? And we're also going to set the current binary gap to 0. We're going to reset the count. Okay, if we're not, we are going to count because we are in a current binary gap, and we're going to add 1 plus equal 1 if we are in a binary gap, else we're just gonna add 0. That's pretty much it. The only thing that we are left to do is to assign the previously significant bit to the current one, so we will know it on our next iteration, and we need to do our right shift, our right binary shift to the right, and we're going to have to return our maximum binary gap count, right? So in order to test this code, when we run the code here, the program is going to run the tests that it has automatically, but here we can also add our own test cases. We should at least add the ones that are in the program description, which are 9, 529. What else do we have? 20, 15, and 32. And we also have 1, 0 for 1. Right, so with that being done, let's run the code and see what it's actually making. It seems like I have an internet connection error. Okay, so the test output is fine. Automatically, the page ran these 3 test cases. We can see our test cases here. So for 9, we got 2, which is correct. For 20, we got 1, which is correct. 529 returns 4, which is correct. 15, 0, it's all ones. 30, 0, there's no binary gap. And 1041, we got 5, which is correct. Okay, so once we have our code running and working, we'll need to do a small analysis of the time complexity of this algorithm. So because it's just a binary representation of a number which has at most 32 bits, the time complexity will be constant time because at most, on the worst case scenario, it will only iterate over the number or over the while 32 times, which is a constant number. So we get that the efficiency of our algorithm is 0.1, which is absolutely great, the best case scenario. So now that we have our code, we can go ahead and submit our task. This might take a little while, usually pretty fast. Okay, and once we refresh the page, we can see that we have a task score of 100 with a correctness score of 100. We can see down here the example test cases that were run for this program. We can see that we have a lot of large numbers with binary gaps that are really large, and it works okay because if you see, all the times are constant, which goes along with our analysis that we have a constant time algorithms. Okay, so that was our first exercise for the Codility lessons. I hope you liked it. I hope that you learned something. I hope that you're encouraged to practice some more exercises, whether it be in Codility, HackerRank, LeetCode, or just grab a book and try some exercises. It's a very good practice to keep your data structures and algorithms, to keep your programmatic thinking fresh. And yeah, that's what this channel is going to be about. So I hope you like it. Please hit the like button, subscribe to the channel, and share it if you think it's valuable or it will be valuable for someone. And I'll see you in the next video. Bye.